Hey everybody, welcome back. And today we will explain the rate of the reactions. What is the rate of the reaction? The rate of the reaction is simply how long it takes for the reactant to be used up or how long it takes for new products set form. So it is the rate, it is the speed at which reactants are consumed or used up or the new products are formed. And this is measurable. So we can measure, how can we measure it? We can measure it by measuring the change in mass, volume, color, or any physical characteristic that can give us an impression about something is going on or something is changing here in the reaction. Some factors affecting the speed of the reaction or the rate of the reaction. For example, the concentration of the reactant. As the concentration of the reactants increase, as the rate of the reaction increases too, and as the pressure of the reactant gases, if the reactants are gases increases, the rate of the reaction increases too. So both concentration of reactant in solution and the pressure of reactant gases are directly proportional to the rate of the reaction. As they increase, the rate of the reaction increases too. Why that happen? What do you think why? Because as we studied earlier in the states of the matter, that pressure can make more frequent collisions between particles, which can give more energy for the reaction to proceed further and faster. So this is if you have more reactant particles in the medium, so as their number increases, they are more likely to collide and hit each other, which can produce energy that will help the reaction to proceed faster. Surface area of the reactant. The exposed area of the reactant molecule. This also affects the rate of the reaction. Surface area is specific for the solid reactant. If the reactant is powdered, the reaction will be faster because we will have more area, more surface area for the reaction to take place. Consider you have a cube of sugar or a powder sugar, and you put each of them in a cup of water. Which of them will dissolve faster? Exactly, the powdered one. Why? Because there is more surface area that is exposed to the medium, to the water, so it can dissolve faster than the cube. So as the surface area of the solid reactant increases, as the reaction rate increases too. And that happens as the pieces of the reactant become smaller and smaller. So the powdered reactant will react faster than lumps. Temperature is another factor that affects the rate of the reaction. So imagine you expose the reaction to high temperature. Imagine what will happen. Do you think reaction will proceed faster or slower? Perfect. Reaction will proceed faster. Why? Because there is more collisions between the particles of the reactions, which lead to the reaction faster. So increasing the temperature accelerated the reaction. The explanation is at high temperature, particles move faster and they collide more frequently and with greater energy. So as they collide, they will get more energy. And this results in a faster rate of reaction. But if the temperature is lower, the particles will move slower and they collide less, and the less energy will be included, so the reaction will slow down. So the rate of the reaction is proportional to the temperature. As the temperature increases, as the rate of the reaction increases, as temperature decreases, the rate of the reaction decreases too. The fourth factor that can affect the rate of the reaction, that can speed up the reaction, is the use of catalyst. Some reaction cannot proceed without catalyst. They need catalyst to proceed, to start the reaction. What are catalysts? Catalysts are substances that speed up the reaction without being consumed themselves. So we add this catalyst. Its role is to push forward the reaction to be faster, but at the end of the reaction, we will retrieve this catalyst again without entering the process of forming the product. It is not consumed during the reaction. At the end of the reaction, we will retrieve the catalyst back without a change. They provide an alternative reaction pathway with lower activation energy. We don't need more activation energy here because the catalyst itself will push the reaction forward to take place. At the end of the reaction, the mass, we will get the catalyst again with the same mass. So the mass of the catalyst remains unchanged throughout the reaction. And adding a catalyst increases the rate of the reaction. So that's all for today. To wrap up, we know that the reaction is reactant, substance react together, and there is a bond break to form new bonds and form new products. This process is called the chemical reaction. This chemical reaction has a rate, has a time to consume all the reactants and convert them to new products. Many factors affecting the rate of the reaction, such as the concentration of the reactant. If it solution, if it liquid, the concentration of solution as the concentration increases, as the reaction rate increases too, because we have more number of particles that can collide more together and can push the reaction to proceed faster. As the pressure of the gas reactant increases, the reaction rate increases too. For the solid, it's a matter of the surface area. As the surface area of the solid reactant increases as the reaction proceed faster, which means powdered reactant reacts more because we have more surface area for the reaction to take place, which can push the reaction to move faster. The temperature is another factor that can affect the rate of the reaction. As the temperature increases, the particles hit each other more and more, producing more energy, which push forward the reaction to be faster. So if temperature increases, reaction rate increases too. The use of catalyst has an effect on the rate of the reaction. So the catalyst makes the reaction rate faster. And this catalyst at the end of the reaction will be retrieved with the same mass without changing in the mass of this catalyst. Thank you guys and see you. Bye bye.